Okay, let's pick up where we left off in class today. So just to refresh your memory, 80%, we believe the null hypothesis is that the proportion of people who pass their driver's test is 80%, 0.8, and that the alternative hypothesis is that it is less than 80% because in the original information, it said 61 out of 90 is what they found to be passing the test. So the alternative hypothesis written out in words would just be the proportion of drivers who pass is less than 80%. That's all. So proportion of drivers who pass is less than 80%. Okay. All right, so the test statistic we are going to use is a z-test because it's a proportion. So the formula is z equals p hat minus the p original, so that's going to be the p original is the population, over the standard deviation of p hat. Of p, standard deviation of p. Okay, so the value in this case is going to be, so now we do the math, 0.678. So where did I get that? I divided 61 by 90 is my p hat, and that is 0.68. So that's our sample is 0.678 minus the population is 0.8 divided by the standard deviation, which in this case is 0.042. Okay, so where did I get that? Standard deviation of the population is going to be 0.8 times 0.2 divided by 90. 90 is in our sample, and so that's where we get the standard deviation of 0.042. Okay, we calculate our z value, and it ends up being negative 2.90. So the question I asked you in class today is, do you think that's very far away from the mean? Yes, that is. That's almost 3 standard deviations away. So I bet our p-value is going to be pretty small. Okay, so a sketch of our sampling distribution. So here's our mean, or the proportion is 0.8. We get 0.678 is all the way down here. And this is that's going to be our p-value. Okay, identify the location of the test statistic in the sketch and shade the appropriate region. The reason I want you doing this every single time is because I want you to get in to see, are you going to have to use a negative large number like negative 100 as your lower bound, and then this is your upper bound? I want you to get used to that. Okay. All right, so level of significance. This is going to be what's called an alpha value. And this is your symbol. Looks like a little fish, but it's the alpha. Okay, we're going to talk about that later, so don't worry about that. The alpha values are usually 0.01, 0.05. So I will go through this later, but those are kind of your benchmarks as you're thinking through this. All right, so shade the approach. Okay, we did that already. All right, our exact p-value, this should actually be a capital P. Our exact p-value when we calculate normal CDF, so you should be doing this in your calculator, negative 100 to negative 2.90 with 0 and 1. Okay, you end up getting 0.002, which makes sense. Now here's where I want you to check. Okay, your alternative hypothesis is less than 0, which means your z-score is going to be negative, which means you're going to be shading this direction. Okay, so all of those will be negative. If they're not, then you did something wrong. You divided wrong here, you subtracted wrong, you didn't use parentheses. So it's great ways to be able to self-check this. Okay. Also, if you're looking at this and it's a really tiny number and you get like 98%, you know you did something wrong. So again, self-check. Know that it's going to be tiny, and we definitely got it tiny. Okay. All right. Critical value. Again, I didn't talk too much about that. If you know these are your benchmarks, these are your alpha values, they are both much smaller. Okay. So what do we want to do? Hoping you're saying it before I say it. okay, we reject the null hypothesis, okay? So regarding the significance, okay, it is significant. We'll talk more about this, significant, okay? All right, and regarding this should be the H sub 0, the null hypothesis. Regarding that, we want to reject because it's so tiny. All right, so how we word that, all right, the interpretation for this, sorry, I'm trying to keep this straight. The interpretation says because the p-value is very low, we reject you could say I reject the null hypothesis. Remember, we're not accepting the other one. I reject the null hypothesis. And then we talk about the survey data. These survey data provide enough evidence to suggest that the passing rate for the driver's test is less than 80%. Okay. Because the p-value is very low, I reject the null hypothesis. These survey data provide enough evidence to suggest that the passing rate for the driver's test is less than 80%. Okay? All right. I forgot. We didn't go back and do the conditions. Sorry. We should have done that first. I forgot about that. So I'm going to slide this down. The necessary conditions. Okay. Same as we've done before. Is it a random sample? Okay. Is it a random sample? Yes, it says. It states random sample. Okay, 2, is it less than 10% of the population? Okay, we assume that 90, there are probably 900 people in a town who are going to take the driver's test. So you would explain the 10%. Okay, so assume that 900 take the driver's test in a city. Okay. And then pass or fail. Pass. Okay. Now, here's a bit of a shortcut. We could say we know that 61 are the passing. Okay, so we don't really need to multiply the proportion times the number. This is the first time I'm telling you can do this. All right, 61 is passing, or the success. And then out of the 90, 29 fail. Both are greater than 10. Okay, so where did I get 61 from? 61 passing, it tells me right here. Then 29 fail. Well, if I know that 90 people were randomly selected and 61 pass, then that means that 29 fail. So 90 minus 61 is 29. Okay? All right, so we're going to flip this over. Okay, I would pause the video, read the question to make sure that we understand what the question is asking. Okay, so the parameter of interest for this is the proportion of home team wins. Okay, all right. Of course, because we have a proportion, we're going to use a 1 proportion z-test. Yes, you have 2 proportion z-tests, and we have different tests with means. Okay, necessary conditions. I'm not going to write this out, but we would go through this. Okay, we can show independence in this case because they are independent of one another playing the games. All right, random. It is a random sample. Let's see. Where does it say that? I mean, it is random. We're looking at. Let's see, if there were no home field advantage, the home teams would win about half of the games. and it's telling you what the home teams are. We're really collecting all of the data in this, so I guess randomization doesn't really work. It's not a simple random sample, but we looked at the whole season, so we would expect the same. All right, 10%. It's less than 10% of all season games, so it's fine. Okay, because we're looking at all of the games that were played. All right, so we're going to be okay. We're going to make some assumptions, but we're okay. All right. Let's see. So the null hypothesis in English would be that there is no advantage at all, and that the proportion is 50%. Okay, so in symbols, we would say that the proportion is equal to 0.5. Here's what gets confusing. You have a p here, but that's for the proportion. Then you have a p-value at the end, but that's the probability. So these are not the same numbers. So just, I forgot to mention that, and I have seen students get confused with that in the past. Okay? All right. The alternative hypothesis, okay? It's telling us, like, is there a home field advantage? All right, so home field advantage. And where am I getting that from? Well, I'm reading the question, right? Teams tend to win more often when they play at home, or do they? Okay, so it's really in here. Do they? We don't know. Do they win more? So we'd say that that the proportion is going to be greater than 0.5. Okay. All right, our Z formula again, p hat minus p for the population over the standard deviation. Okay. Okay, so the value for this is going to be Z is going to be equal to 0.5426 minus 0.5 over, I think I see a mistake on my work actually. The standard deviation, this should be for for the original and for the population, and I calculated it wrong, so we'll do that together right now. Okay, so the standard deviation is going to be the square root of 0.5 times 0.5 divided by 2531. Okay, so we'll calculate that. 0.5 times 0.5 divided by 2531. And you get 0.00994. That's going to go here. 0.009994. Okay, so our Z value is it's okay because you should be doing this math with me. 4.2857 is what I get. Okay, all right. So that's going to tell me with a Z-score, that's 4 standard deviations away from the mean. So that should be telling, oops, sorry about that. That should be telling you that we're going to have a very small p-value. Okay, all right. So here's our center, 0.5. Over here, it's 0.5. Oops, sorry, it should be way down there. 0.5, 426. Okay, all right, and we're going to shade here. That's going to be our p-value. Okay, we calculate the p-value. You should get 0.0001 is what I got when I did it last time. It's going to be probably pretty close to that. All right. My reconciliation, remember I said we're not doing that, but it's going to be very small. So this would be significant. And our rejection we would reject the null hypothesis. You aren't always going to be rejecting the null hypothesis. It is interesting that we have two of them. Okay? All right, so the p-value less or is, what do I have? Okay, so p-value less than 0.0001. Sorry, I'm reading my answer that I did the last time, and I'm confused on what I said. I would reject the null hypothesis. I have evidence that the true proportion of the home team wins is not 50%. It appears that there is home field advantage. Okay, so that's what I would say. Sorry, I'm going to erase this and start over again. I would reject the null hypothesis. I would reject the null hypothesis because the p-value is very small. The data indicates that there is a possibility of home field advantage. Okay. So, bottom line, process. You read the problem, you decide what kind of test are you using. For now, it's an easy choice. You do check the conditions. You'll figure out what is the null hypothesis, what is the alternative hypothesis. You calculate the formula, okay, and you find your p-value and you decide, are you rejecting the null hypothesis or failing to reject the null hypothesis? And that is it, okay? I will give you more practice to do for homework on Thursday night, okay? All right, that's it. Let me know if you have any questions.